This is a limited demonstration of BH curve apparatus. The construction of this apparatus, there is a inbuilt AC power supply with step variable voltages. There is a AC voltmeter which reads RMS voltage directly, and there is a Farad core transformer which is built in and which has 400 turns in the primary and 400 turns in the secondary. There are two parts to this experiment. Number 1, to draw the BH curve, and number 2, to trace the hysteresis loop. Let us perform the first part. To draw the BH curve, you would need a magnetic force on the x-axis and magnetic intensity on the y-axis. You may note that the magnetizing force is the function of primary current and magnetic intensity B is a function of output voltage. To get the primary current, there is a 1 ohm resistor in the circuit. Connect the voltmeter across this 1 ohm resistors. Now vary the supply voltage and note down the voltage across the 1 ohm resistor. Similarly, now connect the voltmeter across the integrator output position and vary the source voltage. Now you may record the secondary voltage in the circuit. Now calculate the values of H and B and draw a graph. Once you have calculated the values of magnetizing force H and magnetic intensity B, you may plot a graph, and you can expect a graph similar to this. Now let us perform the second part of the experiment, that is to trace the hysteresis loop. Connect the input to the Y channel of the CRO or a DSO. And integrator output to the X channel of the DSO. Now select the input source voltage to 10 volts. And if you are using a DSO, as in this case, you may press the auto set button. Now from the menu option, select the XY mode, that is the time independent mode. You will see a BH curve similar to this in the 10 volt position. At this position, BH curve is said to be just saturated. Now use the horizontal and vertical position knob and bring the curve to the center of the graph. Now correlate the voltage of primary and secondary to magnetic field intensity and magnetizing force respectively. Now once you know the voltage corresponding to the magnetic field intensity and magnetizing force, you may calculate the unit volt corresponding to magnetic field intensity on the x-axis in ampere per meter and magnetizing force in Tesla on the y-axis. Now find out the x and y intercepts which corresponds to coercivity and retentivity. Also calculate the area of the curve and you will get the hysteresis loss. For further details, please refer to our user manual.